Mr. Chairman, honorable guests, ladies and gentlemen, it is a very great pleasure indeed for me to be able to attend this meeting. My name is Jiawei Zhang. I am a network engineer from China Mobile Group Jiangsu Company Limited. I received my master's degree in computer science from the Nanjing University of Posts and Telecommunications, supervised by Professor Haiyan Wang. Today, I would like to present our paper, ZSS Signature-Based Data Integrated Verification for Mobile Edge Computing. There are 4 parts: background, related work, our work, and the summary. Part 1, background. Firstly, let's talk about what the cloud IoT is and why they should be combined. Due to the characteristics of Internet of Things devices, their storage and processing capacity is very limited, so it is necessary to introduce their technologies to make up for their shortcomings. Cloud computing can store and process the massive data collected by the devices of the Internet of Things. Therefore, cloud computing technology can be introduced to eliminate the burden of IoT devices through external storage of data, integration of database system, and cloud services. Secondly, the connection between MCC and MEC. Due to the large dimensional distance between the centralized cloud and the portable end devices, conventional mobile cloud computing architectures cannot meet the requirements of low response time and high mobility spot. To address these issues, mobile edge computing has been proposed consequently to augment the capabilities of end devices by deploying edge nodes in the vicinity of end devices. It can offload partial workload from centralized clouds to the edges of networks. Third, what role does data integrated verification play in this? With external storage of data, the integration of database system and the cloud service can eliminate the burden of local storage and supervision. However, remote cloud services providers can certainly gain control of users' data, which rigorously threatens the security of data. Integrated verification is therefore of great significance for reassuring cloud storage. Part 2, related work. Let's talk about what data integrated verification is. Identity authentication can ensure that there is no problem with the data source. Data encryption and decryption can ensure that the data is obtained by the eavesdropper and can prevent the eavesdropper from knowing the content of data. In order to achieve the secure transmission of data, this is necessary to make sure that the data received has not been tampered with by the eavesdropper, which involves the integrated verification of data. This is why we use data integrated verification. What is the MEC? Mobile edge computing technology combines the IT service environment and cloud computing technology at the edge of the network, improves the computing and storage capacity of edge network, reduces network operation and service delivery delay, and improves the user service quality experience. Why use the MEC? Because it is ultra-low latency, quick responsiveness, large volume data storage, so we use MEC to reduce latency and speed up reactions. Part 3. Our work. This is our architecture. There are user, cloud, edge node, and the TPA. The user uploads the data to the cloud, and the edge node downloads and stores the data block in advance. When the user wants to query the data block, it sends a request to the edge node through TPA, and the edge node generates the proof of the data block and returns it to TPA, which verifies whether the data is complete. Our strategy mainly contains of 3 aspects: key generation, signature generation, and integrity verification. After that, we justified our strategy in 3 ways. Specifically, we considered a case that when a single edge node is missing a data block, it will request the data blocks from other edge nodes. If all edge nodes are missing the data block, the cloud will help return the proof of the missing data blocks. The algorithm of our ZSS signature strategy are shown here. We also conduct the performance analysis of our scheme called ZSDIV-MEC. We carried out experimental steps to prove the validity of our model. The figure on the right is the response time of different cases. It can be seen from the figure that our model strategy is superior to the other 2 signatures. We also conduct experiments on key generation and signature generation, and the computational cost of our model was lower than that of the other 2 strategies. Finally, we conduct an experiment on the computational complexity, and the experiment shows that the computational cost of our model is lower than that of other signatures. Part 4. Summary. This paper studies the problem of data integrity verification in mobile edge computing environment. We present a specific system model and a complete solution in the MEC setup for integrated verification. In order to achieve ultra-low latency and acceptable computing overhead, the feasibility, security, confidentiality, and the dynamicity of the scheme are provided. We conducted a series of experiments, and the results show that the performance of the scheme is better than the baseline. In our future work, we will investigate on how to employ blockchain technology into short signature-based integrated verification schemes, and we will also consider data integrity verification problems for multiple mobile users. That's all. Thanks for your attention and have a nice day.